The classification tree algorithm is a C 5.0. This is the algorithm which I am going to use for the classification purpose. So we have to specify the install.packages because C 5.0 is not the default package and will not be available to you directly. You have to install this from the third party different packages. After installing the packages C50, you have to associate this package to your session by require command. The require command will associate the package with the current session, and install packages will complete the installation. Then data iris will affiliate the iris data set with the current session, and the next line head iris will show you the first 6 rows of the iris data sets. So it has 5 predictors, it has 5 attributes and 150 rows. 50 rows for each category we have. 150 rows we have in this data set. You can see this 1, 2, 3, and so on. 50 for Setosa, then 50 for Virginica, and 50 for the next category. So 3 category, each category has 50 elements. But one of the drawback of this data set is that data set is sorted by the help of species. So you have to shuffle the data set because classification model needs shuffling. The very first step that we have to do here is to shuffle the data set on the basis of species. str iris will show you the structure of the iris data set. It contains 150 rows and 5 attributes, 5 columns and 150 rows it contains. And you can see the table command iris species on the basis of species, which is a factor variable. The frequency distribution will be shown. So this is called a frequency distribution of the iris data set with the help of the species variable. 3 categories we have: Setosa, versicolor, virginica. So these are the 3 categories in which we have to classify the data with the help of the 4 attributes: sepal length, sepal width, petal length, petal width. Then this command will do what? This command randomly fix a pointer, random number pointer at the place 9850, so that every time during the training period, if we are using the random numbers, then random numbers will be generated from this point of seeds. The random number will be fixed by using it. Then we will draw the random numbers. How many random numbers we need? As many rows we have in the iris data set, the number of rows in iris data set, and RUNIF. UNIF stands for the uniform distribution. The UNIF stands for the uniform distribution. And uniform distribution is a probability distribution which has the same probabilities for the all numbers. So this is the graph of the uniform distribution. And uniform distribution, R stands for the random numbers. So RUNIF means random numbers from the uniform distribution. How many random numbers are to be drawn? 50 random numbers are to be drawn. And these random numbers will be stored in a variable G. In a variable G, these random numbers will be stored. Then order command will shuffle the random data set. The data set will be shuffled by the order command. So order G, so you have order command is basically a sorting command. So you will sort the data on the basis of G, and all columns will be used from the iris data set. So the comma and after comma leaving the place and writing nothing means all column will be sorted. But now the columns are sorted according to the order of G. So initially the random numbers are random, means haphazard, but after the order command they will be sorted. You can see these four commands, output of these four commands: sepal length, width, petal length, width, species. Four are the numeric and one is the factor. If your species variable is not factor, then you must have to convert it before classification, right? If it is not sorted, then if it is not factor, so you must have to make it factor, because it will not work on a string variable. Now first 100 rows of the shuffle data set is used as a training set. So we are now going to split the data set into the two segments. One segment is called training data set and remaining data set is known as testing data set. Splitting the data set into the training and testing data for the purpose of model training and model testing. Now, first 100 rows, 1:100. First 100 rows of iris data set, except column number 5. Except column -5 means what? Except column number 5. Because column number 5 contains the species variable, which is a class variable. So the command will do what? Training set target column. So you have to isolate the target column. Target column means the class variable. So iris data set 1:100, 5. The fifth, the syntax is what? Syntax is C5.0. C5.0 is the function name which implement classification algorithm. You first have to specify predictors and then comma class variable. That is the format of C5.0. Predictors has to specify first all predictors, and then you have to specify the class variable. So my predictors are except column number 1, 2, 3, 4. Sepal length, sepal width, pedal length, pedal width. These are the 4 predictors. The 5 column are not used as a first parameter. 5th column is used as a dependent variable. The dependent variable is there. So now 100 rows which are shuffled on the basis of species are to be used here. Then model is built and the model is stored in M1. M1 is what? M1 is a variable which contains the trained model. So the trained model, this algorithm will train the model, classification model, and that will be stored into the model M1. Why I am using M1? M stands for the model, 1 stands for the first version of this model. Then summary command will print the output of the model M1. The model M1 will be, summary of the model will be shown. So this is the summary. This is the model 1. just output print of model 1. Model 1 is trained in line number 1. In line number 2, the model output is shown. The default X iris, X stand for the independent variable, Y stand for the dependent variable, comma is there, 4 columns of 100 rows, and 5th column of 100 rows. So this is the model, and 100 rows. Why 100 rows? Because in the training data set we want to use 100 data. First 100 data set for it. Now classification tree, the number of samples 100, number of predictors 4, class variable 1, tree size 4. Tree size 4 means the depth is 4. Now you can see the output. Petal length is bifurcated. If the petal length is less than 1.9, then it is setosa. So we have a child node that is not further subdivided, right? The setosa 34 elements are there. If the petal length is less than 1.9, if it is greater than 1.9, petal width will be checked. If petal width is greater than 1.6, it is virginica. So it is also a terminal node. Setosa is a terminal node. 34 elements are there. 29 virginica is a terminal node. 29 elements are there. Then petal length is checked with versicolor and virginica. So this is the model which is printed by the command, summary command. So summary command, if you issue the summary command, then this output will be shown. But 3 will not be printed because you will use another command for printing the tree or the tree structure. Now, evaluation the training data set confusion matrix. Confusion matrix is identifying 34 element A to A means setosa. 35 elements are versicolor and 31 elements. So in 100% error, 100% accuracy, 0% error means all elements are correctly identified. None of the element is misclassified. So 100% accuracy on the training data set, but we have to check it on the testing data set. So we have to, misclassification rate is 0. It is called overfitting. Underfitting and overfitting, these are the two issues in the model. Overclassification, this is overclassification means 100% it is identifying correctly. If the model is random, so we are not expecting 100% accuracy, we are expecting 90 to 95% accuracy. Even we have a 80 to 85% accuracy, that is not as we are expecting. If it is 90 to 95% accuracy, it is better. But if it is 100% accuracy, this is called overfitting. And if it is a very small accuracy level, suppose 5% or 10%, we have underfitting. Predict command will do what? Predict command will use model 1 on the DF. In this DF, we will use testing data set. So here we will use testing data set. So what DF is? DF is basically the testing data set, and M1 is basically the model 1. Now we want to do what? We want to, in this DF, we do not have the class variable. Class variable is not there, and only the predictors we are supplying to the model 1. Now P1 and table iris 101 to 150 and P1. The fifth column we are going. So this is called actual observations This is called predicted observations. Actual observations we generally represent in the linear model as y, and predicted observations are represented by y cap. So if y and y cap are close to each other, then model accuracy is good. If y and y cap are distant, then we have a very disparity in the model, and the model will not be assumed to be the accurate. So the accuracy level is what? The accuracy is basically the matching of y and y cap, right? Now you can see that 3 misclassified item, because this command will print the table. This command will print the confusion matrix of the testing data set, and this command will use predict. The P1 will be generated by this command, and then matrix will be printed. So this table command will do what? Confusion matrix will be printed. So the confusion matrix is specifying a 3 as a misclassified item. So inaccuracy is what? 3 by 100. Why 100? Sorry, 3 by 50. Because 16 plus 12 plus 19 plus 3. So these are only the 50 elements which we are here in the testing data set. Now 3 by 50 multiplied by 100 is the misclassification rate. The accuracy will be what? So this is inaccuracy. The 1 minus inaccuracy is the accuracy. 1 minus accuracy is equal to the misclassification, or 1 minus misclassification is equal to the accuracy. So the one you can find out these probabilities by subtracting from 1. Now this is the tree. How tree can be shown? The command is shown over with the red color, plot M1. So if you do the plot M1, these tree elements will be shown to you, which I already mentioned in the previous graph. Now another algorithm we are going to use, that is the rpart. It is a classification tree, and in this classification tree we want to use the rpart. Rpart is another algorithm. This is called regression classification. So how rpart is shown and rpart is used. In the rpart command, you first have to specify the species, which is a dependent variable, then all of the independent variable. As this is the same syntax as you use in the LM. In the LM, you use the syntax as dependent variable, the tilde sign, फिर IV1 plus IV2 plus IV3 and so on. So the same syntax you are using as a rpart. Rpart is another classification algorithm which is referred to as regression tree. So species is a dependent variable, sepal length, width, petal length, width, data is equal to data name, method is equal to class. So this is the format of rpart command. Now rpart command, I am going to use rpart command species, symbol of tilde. Instead of independent variable, I used only dot. Dot means except species, all are used here. And data is equal to iris 100. 100 elements will be used from the iris data set, which is shuffled or the jumbled on the basis of species. Now method is equal to classification method in the rpart. Now you can see M3, and another model is to be built, which is named as M3 species dot iris 100 elements, and M3 is printed. So you can see the same output here. Steric represent a terminal node. The setosa is the terminal node, 34 elements in the setosa. So this is a terminal node. This is a terminal node. Terminal nodes are identified by. So we have only 3 terminal nodes, means no misclassification is there. The misclassification rate is still 0 in our part, as we did in the C 5.0. And then this is the tree. 34 elements are setosa, 37 are versicolor, virginica are 29. So you can see these numbers here. And then a classification confusion matrix is printed by the table command. Same command we are using, and same predict command we are using. So P3 is the predict command. Exactly the same command I copied here. But only one thing is changed, and that is M3 instead of M1. If we are going to predict by model 1, we used M1. Here I use M3. M3 has a classification tree by regression. Now output is this. The 2 misclassifications are here, and here we have 4 misclassification. The misclassification rate is 4 by 50, while the misclassification rate was 3 by 50 in C 5.0 and in rpart. So rpart we have a misclassification rate of 4 by 50, and it is better. C 5.0 is better on this data set. Now U2 contingency tables were shown at one slide. So you can compare, this is by P3, 2 and 2, 4 misclassification. 3 and 0, these are the 2, 3 and 0, only one misclassification, which is here, versicolor, but identified as virginica. So these 3 elements are misclassified. And that's all.